One of the greatest, and at the same time, one of the most dangerous elements in the history of mankind is fire. Early humans first discovered and used fire approximately 1.7 million years ago. However, the fossil record of fire dates back to over 470 million years ago, during the Ordovician period. Planets are diverse in their compositions and conditions, and while some exhibit extreme temperatures, they lack the essential components for traditional combustion. In other words, Earth is the only known planet that has fire. Now, take Venus for instance. Surface temperatures can soar above 450 degrees Celsius due to a thick atmosphere which traps heat. However, the extreme temperatures are a result of the greenhouse effect and not a traditional combustion or burning as we see on Earth. The Sun, which is a star, is not fueled by the same combustion process as fire on Earth. Instead of burning, the Sun undergoes a nuclear fusion reaction in its core, where hydrogen atoms fuse together to form helium, releasing an enormous amount of energy in the process. This process, known as thermonuclear fusion, occurs under extreme temperatures and pressure, creating the intense heat and light that we perceive as sunlight. Scientifically, volcanic magma is not fire. Magma is the molten rock found beneath the Earth's surface, typically generated by the intense heat and pressure in the Earth's mantle. This superheated magma can sometimes surpass temperatures of about 1200 degrees Celsius. Now, the big question is, what exactly is fire? At a very fundamental level, fire is a rapid chemical reaction known as combustion. Combustion involves the interaction of three essential components: fuel, oxygen, and heat. These components form what is commonly referred to as the fire triangle. Without any of these elements, burning or the combustion process can never occur. Fuel. The fuel for a fire can take various forms, including solid materials such as wood, paper or cloth, liquid substances like gasoline or alcohol, and gases like propane or natural gas. The nature of the fuel influences the characteristics of the fire, such as its color and temperature. The second component, oxygen, is a critical component of combustion. During the process, oxygen molecules from the surrounding air combine with the fuel, producing heat and light. The availability of oxygen is a key factor that determines the intensity and sustainability of a fire. Apart from Earth, other celestial bodies in our solar system have insufficient or absent oxygen, rendering fire impossible. This is why fire only occurs on Earth. The last component of combustion is heat. Heat is the energy required to initiate and sustain the combustion process. The heat necessary for ignition can come from various sources, such as a spark or open flame, or even spontaneous chemical reactions. Once ignited, the fire generates its own heat, creating a self-sustaining cycle of combustion. In addition to the fire triangle, modern fire science introduces the concept of the fire tetrahedron. This expanded model includes a fourth element, which is a chemical chain reaction. The chain reaction represents the ongoing process of heat generation, fuel consumption, and the release of additional heat and gases. The colors of fire are predominantly determined by the chemical composition of the burning material. Different elements emit distinct wavelengths of light when heated, leading to a spectrum of colors. The temperature of a flame also plays a crucial role in determining its color. Some of the most common colors of flame are red, orange, yellow, blue, green, and purple. Among all of them, blue flames are the hottest. Hydrocarbons, such as those found in methane or propane, burn with blue flames at higher temperatures due to the increased energy release during combustion.